Server farm. A server farm or server cluster is a collection of computer servers usually maintained by an organization to supply server functionality far beyond the capability of a single machine. Server farms often consist of thousands of computers which requires a large amount of power to run and to keep cool. At the optimum performance level, a server farm has enormous costs, both financial and environmental. Server farms often have backup servers which can take over the function of primary servers. In the event of primary server failure, server farms are typically co-located with the network switch and the routers, which enable communication between the different parts of the cluster, and the user of the cluster. Server farmers typically mount the computer routers, power supply, and related electronics on 19-inch racks in a server room or data center. Web hosting is a common use of a server farm. Such a system is sometimes collectively referred to as a server farm. Other use of server farms include scientific simulation, such as computational fluid dynamics and the rendering of 3D computer-generated imagery. Increasingly large companies are turning to server farms to replace or supplement mainframes computers. However, it's important for decision makers across the enterprise to understand that server farms do not yet offer the same degree of reliability as mainframes. Due to the sheer number of computers in large server farms, the failure of individual machines is relatively common. Fortunately, most data centers and internet service providers (ISPs) take this into account by providing advanced support for redundancy, automatic failover, and rapid reconfiguration of the server cluster.
Data center, also known as a data center of data center, is a facility composed of network computers, storage system, and computing infrastructure that businesses and other organizations use to organize, process, store, and disseminate large amounts of data. A business typically relies heavily upon the application, services, and data contained within a data center, making it a focal point and critical asset for everyday operation. Enterprise data center increasingly incorporate facilities for securing and protecting cloud computing resources, as well as in-house on-site resources. As enterprise increasingly turn to cloud computing, the boundaries between cloud providers' data center and enterprise data center become less clear-cut. How do data center work? A data center facility enables an organization to collect its resources and infrastructure for data processing, storage, and communication, which include systems for storing, sharing, accessing, and processing data across the organization, physical infrastructure to support data processing and data communication, and utilities such as calling, electricity network access, and uninterruptible power supplies. Gathering all these resources in a data center enables the organization to protect proprietary system and data, centralize it in data processing, employees, contractors, and vendors, apply information security controls to proprietary system and data, and realize economies of scale by consolidating sensitive system in one place.
Green computing, also known as green technology, is the use of computers and other computing devices and equipment in energy efficient and eco-friendly ways. Organizations that use green computing methods often deploy energy efficient central processing units (CPU), servers, peripherals, and power systems. They also focus on reducing resource use and properly disposing of physical and electronic waste. One of the early green computing initiatives in the United States was the Energy Star Labeling Program. This voluntary program was developed by the Environmental Protection Agency in 1992 and implemented by manufacturers to promote energy efficient in computing hardware and other types of appliances. The Energy Star labeled is common especially for laptop, computers, and displays. European and Asian countries have implemented similar programs. What is included in a green computing strategy? IT managers typically focus energy efficient efforts on data centers, equipment rooms, storage areas, and other elements that use energy or are affected by energy use. Saving money is one driving factor. Government regulations dealing with energy conservation also drive green efforts. Concern about climate change, along with internal and external pressure to be environmentally responsible, is a third factor behind the green movement. Companies' green computing strategies can include the following steps. Remote work. The COVID-19 pandemic has spurred many changes in the workplace environment, including ones that have led to reduced energy consumption. It has decreased the number of people commuting to and from work. It has also cut the number of employees present in an organization's facilities, reducing demand for power, water, and other resources. Smart technology. Organizations can use Internet of Things sensors and artificial intelligence monitoring tools to collect and analyze information about the data center and create a power usage model. Powered tools can also autonomously manage heating, cooling, and power in the data center. Upgrade and rearrange the data center. Older equipment often uses more energy and puts out more heat than newer devices. Hot and cold AC setups can be used to group assets based on energy consumption and temperature. Optimizing heating, ventilation, and air conditioning efficiency. Power down. CPUs and peripherals can be powered down and turned off during extended periods of inactivity. Power up energy intensive peripherals such as laser, printers, and only when needed. Strategic scheduling to computer related tasks and dedicated blocks of time, leaving hardware off at other times. Display selection. Liquid crystal display monitors use less energy and give off less heat than cathode ray tube monitors. Computer selections. Laptops use significantly less energy than desktop computers. Power management. These features can be set to automatically power down hard drives and displays after several minutes of inactivity. Temperature check. Newer IT devices can safely run at higher temperatures than older ones, so the data center may not need to be as cool as in the past. E-waste. Dispose of e-waste according to federal, state, and local regulations. Alternative energy. Investigate alternative energy sources such as geothermal cooling and wind and hydroelectric power. The importance of green computing. The key mission of green computing is to reduce energy consumption. This not only cuts energy costs for organizations, but it also reduces the carbon footprint, particularly of IT assets. The environmental impact of IT components is important in the study of data center design. Advances in energy management and energy conservation have turned computers and other computing resources into highly energy efficient assets. Green design of data centers, office buildings, and other highly energy assets has become a key part of new constructions and building upgrades to make them more environmentally sustainable. An important consideration with green IT is to reduce the use of energy from fossil fuels. This helps lower the amount of pollution released into the atmosphere and water system. Reduced emissions have been shown to have positive effects on weather and air pollution. Building energy considerations into the system's development life cycle has resulted in the use of energy-efficient equipment, power systems, lighting and HVAC systems, and a variety of ancillary systems. For example, many data center components have a sleep mode that reduces power use or completely shut down a system during times of low or no use. Most IT equipment manufacturers support green manufacturing. As noted earlier, the Energy Star logo is an important metric when selecting IT equipment and data center elements.